vertical asymptotes, we are going to simplify and factor and cancel. Anything that cancels, those will be wholes of the function. And then whatever is left over, that is what we set equal to 0. And those leftovers give us the vertical asymptotes. And remember, when you're talking about a vertical asymptote, you're really having this blowing up of the graph, and that blowing up is causing or being caused by the fact that the denominator is very, very small. So that's why we're setting the denominator equal to 0. All right, so if you look at this question here, you have x or 12x over x squared minus 144. So the first thing that you would do is you would say, okay, can I factor and then cross out any common factors? And when you look here, there is a way to factor, of course, and we have our difference of two squares. Remember, we are subtracting two perfect squares, so we can use the difference of two squares formula that says that we take the square root of the first, so that would be our square root of x squared, and the square root of the last, which is just 144, not the negative. So that will give us x and 12. So we will have x plus 12 and then x minus 12 plugging into our difference of two squares. One thing just to mention, please remember that if you have a sum of two squares, that is prime. So you cannot write x plus 2 because then you would have the middle term, so that doesn't work. And you can't write out x plus 2, x minus 2 because then you would have a minus 4 for the last two multiplied together. So it's only a difference, a subtraction, that actually works for factoring. So in this instance, what I would do is I would say, okay, I can factor this as 12x over, and then x plus 12, x minus 12. And at this point, we see that nothing cancels out. And so because nothing cancels, I would have to then go to my step 2, which is where I set my denominator equal to 0. So here I have x plus 12 and x minus 12 as our denominator. When we set that equal to 0, it's important to notice that because we have parentheses, that is factored. And when it is factored, you can just set each of these factors equal to 0. So we don't need to distribute or anything. We just need to set x plus 12 equal to 0, and then set x minus 12 equal to 0. And so when we do that, we get negative 12 and positive 12. So our vertical asymptotes would be exactly this. X is equal to negative 12 and x is equal to positive 12. Now, just as another example, when you look here at 5 over x squared plus 25, as we discussed, there is not a way to factor the x squared plus 25 because of the fact that this is a sum of two perfect squares. And when you have a sum, that is prime. So there's nothing to do as far as trying to factor that. So if I needed to find my vertical asymptotes, I would set my denominator equal to 0 because it is already simplified. We tried to factor, there's nothing to do, so we just set our denominator equal to 0. And when we do this, we get x squared plus 25 is equal to 0. Again, because we cannot factor, the highest power here is 2, so we have our quadratic methods. So we could, if we wanted to, we could go through the quadratic formula, or because we have x squared and a number, we could use the square root method. So the easiest thing to do is just going to be to isolate this x squared and then take the square root. So we will have x squared is equal to negative 25, and then we take the square root of both sides, which gives us x is equal to plus or minus 5. And then remember that the negative that is underneath the square root, that is defined as I. So we have a negative 25 underneath the radical, that becomes plus or minus 5i. Now, remember that what we are trying to do is we are trying to find the vertical asymptote. And the vertical asymptote would be on the Cartesian coordinate system as a line that we're approaching but not actually touching. The issue here is that x has to be real and y has to be real. So when you get this imaginary number, because we are talking about a function that we are graphing, we will ignore our imaginary numbers. So we did find two vertical asymptotes, plus or minus 5i, But again, if we were to try to graph plus or minus 5i, there's no place on the Cartesian coordinate system, the real Cartesian coordinate system, to put the 5i. And so because of that, ignoring the imaginary numbers, we would ignore this solution, and we would say that there are no vertical asymptotes.